Hi, it's Gadget UK here again. As you can see, this time I'm looking at a Commodore 1084S, so the S designates stereo. I think so. Yeah, I've got two speakers built in left and right, and yeah, I've seen on the back there's two phono RCA jacks for that. I'll show you the connections and things on the back in a minute, and some of the controls on the front. I mean, I can just tell you the controls, and I've got a volume there. There's a green button, you just push it in and it goes green screen. Push it out, you get colour. There's a colour dial there, contrast, brightness, horizontal phase. The power is around the back on the right. It needs a new power switch. Switch it on now. See if I can show you this. Yeah, it came on and went off. But if you just tilt the switch to the right, I'll show you in a minute. It grips and stays switched on. So I'll switch. I've got it connected to the Atari 65XE here. Let's just see what happens. Yeah, so you can see it jumping all over the place there. So on first inspection, you could be concerned that maybe there's something wrong with the tube, or maybe the line output transformer or something. And I think that's what the seller thought with this. But the telltale sign when the transformers go on these is you get like a whine and nothing at all. You know, you won't feel the HT there, whereas obviously this is working. I suspect it's caps, this. We've got colour for the minute. I tested it earlier and we had black and white only. I'll test it with some other systems and things. I might get the PC Engine onto it in a minute and try that, but I suspect if we leave this for a period of time now, maybe for 20 minutes, well 10-15 minutes ish, I suspect it might stabilise at some point. I'm thinking actually could be something on the power supply section. You know, if I cut the supply there, you know, the input, can you see it's like a bit of a collapsed frame, just a little bit. And then with these flyback retrace lines here as well, you know, you've got two things going on. So we'll just leave it a few more minutes, but yeah, I think it's caps on the power supply side. Yeah, it's very close to getting there now, I think. You can see this band at the top here, and it's just flickering a bit. But yeah, let's just cut the feed, let's just see what it looks like. The frame's a little bit better. So we'll just give it another minute or two. Yeah, you see, I think it's a power supply thing, I really do. Could be the tube, but I don't think so. Yeah, it's very nearly there now, it's just wobbling a little bit, it's starting to stabilise. Yeah, that's relatively stable actually. Yeah, I think actually this monitor perhaps only supports a PAL composite signal. I think that's probably what we're seeing here. You can tell me it's working, speakers work and stuff. Let's turn the volume down a bit. It does need recapping. What I can do is take the back off, get the freezer spray, obviously make sure there's no pets or toddlers or anything around when you're doing this. But yeah, take the back off and then just target one cap at a time with freezer spray. Switch it off, switch it on, you know, well, switch it off, freeze it, switch it on, and see if the frequency issues come back where it can't sync and stuff. And that'll help me narrow down to work out which cap it is. Also, you know, strictly speaking, I perhaps should recap the entire board, but there's probably about 60 odd or 70 odd caps on there. I really don't want to go through the whole thing. And typically, ESR problems are, you know, associated with specific points on the board generally, unless it's like a bad batch of caps. But I don't think that's the case. I think it's going to be one cap that's a bit stressed from, you know, usage over the years. So that's the approach I'll take to work out the cap. But in the meantime, I thought I'll switch this off now, and I'm going to wire up the Atari 65XE because that's PAL, and we'll just see if the colours are there or not. Yeah, so I had to press one of the switches on the back. That didn't make any difference when I had the PC Engine connected. So maybe because it's you know, NTSC, that was why that wasn't working. But we've got a blue, I don't know if you can see that, a blue screen up now actually, and I can adjust the colour. There you go, it's a bit stronger. So I mean, it needs some adjustments this monitor. The convergence is not spot on. You can see like the green, we've got like a bit of green line to the edges there, and it's just in a little bit, but that's because I squashed it in to get the PC Engine to fit on screen. And again, like I say, it might need properly recapping. You know, can you see it's a bit bent towards the edges there? But yeah, let's load a game up, see what a game looks like on it. Seems alright, we've got colour. Yeah, that's working sweet. Yeah, and after 5 minutes of powering up there, as you can see, that's working. Now you might get flickers coming down, you know, bands coming down because of the way that it's, you know, the image is drawn on the CRT. But to me, the picture's absolutely solid, crystal clear. I did have a play with the colour. That's the centre point, and that's the centre point now. You can see it's not very much colour going on. You only turn it up a bit. That's maximum. Maximum looks where it should be on normal. Actually, just turn it down a little bit. Yeah, that's not quite on the medium setting. You know, the standard. There's like a little notch in the middle, so that's probably about 65-70% the way around, and the colour looks pretty good. So I mean, there's no telling how much usage this tube's had. It could be the tube's pretty warm, but I think the fact that it's okay now, I've got a stable image after it's warmed up, that leads me to believe that it's a capacitor issue. So I think the next thing we'll do here, before doing anything else, is swap out that switch. And I don't know whether you can see, the end is sheared off as well. The tip of the switch is stuck in the plastic housing there. So we've got two issues there. Might be quite difficult to get the piece out. I'm not sure how I'm going to do that. But anyway, yeah, so it's just going to be a case of desoldering the connections here under the switch. I've got a replacement switch here. You can buy these, there's a couple of sellers online actually, but this one came from The Future Was 8-bit. Hopefully it's going to fit. I might need some adjustment, I'm not sure. Yeah, I don't know if you can see that. The profile there is correct. If you look at the connections, you know, the way the bottom two are offset, that should be okay. So yeah, I'll desolder the old switch. So I've just got the last few connections here. I'll just show you, just adding a bit of solder with flux, and then using with a solder pump. I'm doing this sideways. It's perhaps not the best way to do it, because you can get solder running down the board if you're not careful. I'll be better off disconnecting everything from the chassis, which I might do in a minute after I've done the switch. I'm not sure, just in order to get better access to some of the caps and things. It's a bit difficult at this point here because you're right near that plastic post that you can see. So I might just need to just change the angle of the iron here slightly. Yeah, the solder pump's a bit blocked now. This switch has got two extra connections there actually. I need to check this. Might be able to cut those off, they might not be needed, but I'm not sure why we've got those two extra connections, because they aren't on there. There are no connections down here. So whilst it might fit, that could cause me a problem. Yeah, the subtle difference there is not going to be a problem. I'll show you. I've got my meter on continuity here. This switch is switched on, I think, at the moment, is it? No, it's not. Switch it on. So this is the new switch. So you've got a short between those two, switch it off. They open up. And similarly on this side here, those two, switch it on. They're short. I'm guessing these perhaps short at some point. I could be wrong. Yeah, that's a bit weird. Not sure exactly what those contacts there are for, but I can trim them off. I'll show you. This is off. Switch it on. Again, short between those two. Short between those two. Yeah, that's right. And you can see the tip. You know, the tip is snapped off there. So I'm going to have to get something in there to prise that out. I might just be able to just use my fine nose pliers. There you go. I managed to pull it out. Thank God for that. So yeah, two issues with this. Like I say, it doesn't stay on. It's not latching. And the tip's broken off as well. I might just take that apart actually, out of curiosity. I mean, you can see it's you know, it's welded. There's plastic welded and melted. So you can't really, you know, it's not serviceable. But I'm just curious to see what's gone wrong with it anyway. I'm guessing one of the little plastic notches has broken off inside it or something. The part where it actually, you know, latches on a spring or something. So I've chosen to fold them over like that. Actually, I could just trim them off, but to be honest, as you can see, sorry, hopefully it's not very clear, there's nothing underneath the switch. In order to get it back in the case, the best way to do it is to stick the switch on the end there, so that and switch it on, so it's shorter in length. So it should then, in theory, be able to just push it in that way, you can see, and get the connections in the right place. With a bit of manipulation, we should be good, I think. Yeah, that's it. I should just be able to solder that back in place now. So that's the final solder point there. I'll just clean it up with some cotton buds and IPA, and then just reassemble it and just test the switch. So I've just taken this to par. Let me just show you, this plastic is mega brittle. It just crumbles. It's come off in tiny pieces. But the problem with this, might just put you on macro, is, can you see the underside of here? You've got this little channel sort of thing going on. So you can point with this tool here. There's like a little notch that slides around the circumference here and hooks onto there when it's to that middle position when it's locked. So corresponding to that under here is this black piece of plastic, and this is supposed to be, you can just see a dot there, it would have had a notch stuck up where, like say that channel can toggle between I think so anyway. That looks like it. It looks like it slides. This does it? Yeah, it does. Can you see that? It slides. So it's that piece there. The notch just broke off it. So yeah, nothing you can do with it. And the fact that it crumbled to pieces and it's it's got these little plastic bits moulded, melted on it. They're not serviceable. But I just thought I'd just go in there just to see how it failed. So just wait for it to warm up again here. There's a few things I just want to cover here. I've mentioned them briefly on some of my other videos in the past. Safety warnings to do with DC, high DC voltages when you're dealing with switch mode power supplies and things like that. But this is a whole other level of risk. You can seriously kill yourself very, very, very easily working on something like this if you don't know what you're doing. So I would recommend, if you're not an experienced electronics engineer, you've certainly, you're not aware of the safety precautions and things, and stay well away from doing something like this yourself. The line output transformer, and I'm nowhere near it here, I'm about a foot away, that black thing there, can you see the red cable coming off when it goes all the way up here into the tube? You've got 24 kilovolts, 24,000 volts DC on a colour monitor typically, something around that figure. It might be about 10-12 kilovolts for a black and white monitor. Yeah, it's been a long time since I worked on these, so yeah, don't quote me. I think that those figures are just what I've stuck in my mind from back in the day, but yeah, around 24 kilovolts. It might even say on the tube somewhere, sometimes it usually does, I think. But the point is with DC, you get a shock off AC, what happens is you get like if you imagine the AC, you've got a sine wave, yeah, plus and minus cycles, positive, negative cycles with AC. The effect that has on your muscles, we are driven by electrical signals as far as I understand. It's electricity that drives your muscle actions. You get AC going through a muscle and you spasm, so it can almost like throw you away from something. You touch, you'll have had this yourself if you've got a shock off the mains, you sort of get thrown away from it. Your reaction is to sort of, like that. With DC, if you touch something, say this is electrical, I touch it there, you go rigid. It's it's DC, it's direct current straight through your muscles. You become totally rigid. You cannot even separate yourself from something. And if anybody comes and tries to move you away from whatever it is you're being electrocuted from, they can join the chain and they get electrocuted as well. So it's lethal. High voltage DC is lethal. But in general, yeah, anything that's high voltage DC related, stay away from it. But as long as you keep your distance from things like this and you're very, very careful and you know what you're doing, they are safe to work on. It's like I say, you've just got to pay a lot of respect for the HT part of these circuits. So it's still warming up. You can see we've pretty much got a stable picture. Strangely enough, it just inverted, then it went white and then it went black. But what I've just been doing is using my freezer spray here, switching it off, obviously wait for it to stabilise first, switch it off and then freeze a couple of components. So I went round some of the caps here, some of the ones down here, various places all around, including on the back of the neck board there, to try and see if I could work out which cap, because in an ideal world I should perhaps recap the whole thing, just swap out every single capacitor on this. It's it's had a lot of usage in its life, but to be honest it tends to be just specific caps that get hammered in in systems like this, where you've got maybe where you've got very high switching frequencies and things. those are the caps that tend to go. Any that are near heat sinks, or it could be, you know, like we've had in previous videos where you get a specific manufacturer or something, a part that's perhaps not within the temperature range it should be, you know, maybe they put an 85 degrees cap in there and it should be 105, you know, or let's say things close to heat sinks and stuff. But yeah, so typically you're only going to need to swap out a bunch of caps, maybe the ones on the switching power supply side of things, and maybe the one related to the line output or the frame stuff. Those are typically the ones that will go on these. And just spraying around, I managed to, I'm not going to go anywhere near this actually because I'll end up killing myself. I'll zoom in on it. Cap in the middle of the shot there, just next to those heat sinks. Can you see it? Just with the red wire sort of going over it and the green wire, the grey wire. Yeah, in fact it's behind that little transformer. Can you see there's a little yellow transformer in front? That electrolytic there, that is the one I believe is the problem. And to test that theory, as you can see, hopefully, we've got the picture back up now. It's took about another 7 or 8 minutes for that to stabilise. So what I'm going to do is, in fact, I'll just point you at the screen if I can, just so you can see a bit of both. You're not going to be able to see everything here, move you back a little bit. I'm going to switch it off, switch it back on, just make sure the picture is still there, because that's the key. You know, if it cools down, if you just switched it off and on, you may find that the fault has come back, and it hasn't. That's good. You know, it causes you a red herring scenario where you spray something, you think you've got the component, you haven't. So I'm just going to switch this off again. I'd spray that cap. Switch it back on. Let's just see if there's any change in behaviour, because it may be something near that cap. It might not be that capacitor. In fact, it doesn't look like it is that capacitor. Now there are a couple of resistors there. I'm just wondering if I'm barking up the wrong tree here, and maybe it's not the cap, maybe it's the resistor. There's also a cap behind it. I may have inadvertently sprayed that. So I'll just try again, give it another blast. Switch it back on. Yeah, I'm not that lucky. It isn't that cap. So let's spray. There's another cap there. Let me try that one. Even that HT noise, you can hear it, that static noise there, scares the shit out of me actually when I'm working on these things. I hate it. So using that technique, I think I've found the problem. I'll zoom in. I might give you a macro in a minute. I don't know how close I'm going to get. Can you just see? Try and touch down here with that. Killing my bloody self. You see this little resistor here next to the heat sink? It's like black in the corner there, and spraying just around that local vicinity there seemed to solve it. So I think we've got a resistor that's almost burnt out, I think. And I actually think that resistor's alright. I've had a close inspection, it's about as near as I can get with that macro. I'll try and put your macro in a minute. See if I can get something to point with. Bear in mind it's unplugged. I'm not going to electrocute myself here. See where the that little resistor there just above the screwdriver. Can you see what we've got? And this is thanks to 12 volt vids actually. You should check out his channel. We've got some mounting epoxy there, you know, they use like that. I don't know what it's called, you know, it's like an epoxy sort of thing, a glue they use for sticking on wires and things like that on heat sinks to stop vibrations and stuff. And what seems to have happened is it seems to have become conductive, and it's having a reaction where it's making a connection between this heat sink and the end of that resistor. I mean, the resistor still could be shot, but I don't think so. I think if I scratch it off and clean that area up, I suspect this is just going to spring back into life. And whilst we're here, I'll tell you another story as well. When I was younger, I got next to the line output transformer here, was trying to do a measurement or something, and my hand must have just brushed just near where it was leaking. And what I mean by that is some of these, you know, sometimes you get like ozone. Well, you nearly always get ozone produced by these line output transformers because of the high voltage. But sometimes they leak. The transformers, you know, they're supposed to be sealed. Sometimes you get like a little air gap leak there somewhere. And I just got too near it while I was trying to do a measurement on another part of the circuit there. And I got HT straight in my arm. It lasted all of about a second. It was like a whole second, but it seemed like an eternity. And somehow I miraculously fell away from the monitor, but that was near lethal. I was soaked in sweat. I was like in shock. I was just on the floor, absolutely soaked. I've never sweat so much in my entire life. I think I suffered a heart attack at that point. So I was really lucky, you know, because with things like this, let's say, if anybody's, you know, you get a shock from DC, you remain attached to the device, if you're not, you know, more often than not. And if anybody tries to free you from the device, not realising you've been electrocuted, they join the chain. So yeah, be warned, stay well away from CRTs unless you know what you're doing. But yeah, so I think, like I say, I think I'm going to clean that that area down there up and just retry it and just see what happens. So I managed to get in there with some small tools, you can see, cleaned up, and then used some cotton buds and IPA and just wiped away all the residue and stuff from around that area. It looks super clean. There's a possibility that cap next to it needs swapping out, may have leaked. I'm not entirely sure. It does look alright, but yeah, that might be the next port of call, I think. And whilst we're here, I'm not an expert on monitors, I'm really not. This is something I probably fixed, I don't know, a good 100 monitors in my lifetime, but not very many compared to some of the other engineers, and it wasn't an area I excelled in or anything like that. They're quite complicated beasts, though they can be, and they vary so much, you know, generally, but you get the same sort of common things within all of them. So for example, you've got a degaussing coil, if you're not aware. It's a coil that goes all the way around the tube. When you first switch it on, you get high voltage sent across there. It might be mains sort of level, I can't quite remember now. Across these, you know, through these two wires, just goes round the tube, and it generates, or I think it just counters any magnetic field imbalances you've got. So, you know, say for instance you stuck a speaker in front of here. Whilst it's on, you'll affect the colours, and you can leave horrible colour patterns and things on the screen because of the magnetic field. And this just sort of resets that, if you like it. You know, it's like it degausses it. It's just a short burst there when you first switch it on. That's what that does. And then you can have switch mode, power supply stuff here, probably. And then the transformer, as I mentioned before, is your HT, HOT, line output transformer. It's called various things really, but yeah, LOPT, line output transformer. There'll be a transistor that goes with that, you can see down there on the heatsink. And obviously, I forget which way the anode and cathode. Is it your cathode? I think it is your cathode. But you'll have a connection goes to the back of the base of the tube here, the neck of this neck of the tube. This board usually comes off. You can see it's glued on. I'm not going to take that off because it's making a good connection at the moment. I don't really want to separate it, and there's no need to. But this will slide backwards off there. You've got to be very, very careful with tubes, because, you know, any force on this glass here, you know, say for instance you tipped it on its side and it fell onto the neck of the tube, smash, that's it. You need a whole new tube. Yeah, so anyway, your line output transformer connects to the tube in the two places, like so on the backboard. And here you've also got the vertical. So the line output transformer, what that does is, if you imagine your picture, if I just point you down at this, is probably the easiest way to do it. Yeah, you need to control the electrons, you know, the electron beam that's going across, because that's the way it works. If this was a display now, it starts at the top here and it goes across like that, and then it flies back. That's where the name flyback transformer comes. You get a flyback to this position here, and it continues to draw like that. But you know, so you've also got something that drives the picture in that direction. You know, it moves the electron beam down. You know, and that's done by the vertical section, which is, it could be this chip here. I know this. It could be the one. I think it's probably the one on the back of that heatsink there. Actually, the vertical deflection. So you know, you've got horizontal comes from the line side, and the vertical is done, let's say, usually by a discrete IC there. Sometimes a couple of transistors or something. I'll just flip this around. I'm going to be careful not to damage anything here. Yeah, it's going to be that chip there. There's usually like a TDA something or other. That's usually for your vertical. So if you ever get it where the picture's collapsed like that, you know, you just get a line like that, it's going to be the vertical. If you get a line like that, it's going to be the horizontal. Sometimes you just get a dot when both have gone. You know, if you ever see a screen with a dot in the middle. I could be wrong. It's like I say, it's many years since I worked on this stuff. I mean, it is a real incredible amount of time. I'm amazed what I'm actually remembering now, to be honest. And you can see you get the deflection coils. The bit that does the deflection is here. You know, you've got connections there for horizontal and vertical, and they come up here onto the back of the tube. See the four connections there, and that's what this assembly here of these coils is to control the XY deflection of the electron beams. And you typically on a colour monitor, well, not typically, well, yeah, there are different scenarios, but on something like this, you'll have three guns in there, red, green, and blue. I don't think they're marked on here yet. Oh, it is actually. Yeah, if I just turn it around. Yeah, these are the cathodes. So EHT cap at the top, that's your anode, and these are cathodes because they're marked. And let's see if we can show you this. You might not be able to see it. If you look at the little connections to the neck of the tube there, you've got GK, that's green cathode. A bit further up you've got RK, red cathode, and then over to the top, second from the top right there, you've got BK, blue cathode. So yeah, so that's where your colours are driven, and obviously there's going to be other things on this board. You can have your RGB input and stuff to deal with composite and separating the colour and stuff. You know, this particular model will work only with PAL, I think. There's probably going to be a crystal or a what's it called, a line delay, or is it a line delay somewhere on here that means that this is sort of kind of factory locked to the PAL colour burst frequency or whatever it is. So you could probably do a mod. It might be that crystal down there, I don't know. Yeah, so you could probably do a mod to get it working with NTSC, but I think I did test this earlier with a PC Engine and it was black and white, and that's going to be why. Like I said, this is designed to display PAL signals really, although it will work with 60 Hz, no problems. And just before we reassemble it here, you can see the connections where the line output transformer connects underneath. These are a common point of repair, if you like, on 1084 monitors and other monitors as well. It's not uncommon to get a crack, around one of the connections here. So it's important. So if you've got a problem where it seems completely dead, or you've got a problem with the line side of things, to reflow those. They're all right though. Those have been done by whoever looked at this before me. I have had a good thorough inspection around the board for dry joints, but and you'll get them in other places as well. It's not uncommon, if I just turn this back over, it's not uncommon to get bad solder joints underneath, the point where that joins, your deflection coils, and sometimes on the neck of the tube. Sometimes you can get bad connections there as well, or on the degauss, the degauss coil connector down there. But yeah, other than that, there's nothing much more to do with this. I could recap it, I might do that at some point in future, but right now I think I'm going to just continue inspecting around the board. See, there's some glue there, can you see that? Sorry, just down there, but it's not gone yellow. Now there is a jumper right next to that, so if that became conductive, yeah, it could be a problem, but then again, it's not going to be making contact with anything else. It's probably alright. You need to look for scenarios where that glue is touching to contact, because that's where the conductivity thing becomes an issue, and I can't see any other instance of that on here, and it seems to go like a dark yellow rather than the white or cream colour or whatever it is there. So it seems to be just on this particular one I've got here, it's just that one instance next to the vertical deflection IC where there's a resistor, just next to the heatsink of that vertical deflection IC. So I think that's what's been going on. It must have been maybe, I'd like to look at the schematics later to perhaps see if I can work out what's going on, but I'm just wondering if that heatsink was grounded perhaps, and the vertical deflection supply rail or something was going through there. Maybe we were just losing the vertical. It did kind of look a bit like it was at a vertical collapse or something to start with, but then again it wasn't frequency locking either. It was like rolling round, like there was some sort of sync issue or something, and if I'm honest, it almost looked like the line level wasn't strong enough either. Initially I suspected maybe a cap on the power supply rail, maybe the main, the one associated with the main switching part of the power supply there. I wondered if we had like a slightly reduced main voltage and it was just gradually coming up, but I don't think so. I think it's just whatever that resistor was connected to that heatsink, that it's the relationship between those two joining up there, pulling something low perhaps. Yeah, lucky nothing else got damaged. Anyway, I'll reassemble it in a sec. So I might need to go back to the service manual actually, because I'm not sure. This is the right hand speaker, the red one. I'm guessing it's going to be right and left. There is some text on there, I can't quite read it. I might just have a quick look. If it's not right and left, I'll let you know. So I've got two of these screws here to go on the back there. If I can just find the other one, where is it? There. Yeah, and then there's a screw there and a screw there on the base, and then we've got the four screws, obviously, around the corners of the thing there. And incidentally, this screw here was missing, so that it really annoys me when they do that. Someone who was in this last couldn't even be bothered to put the fourth screw on the back there. I don't know, he must have lost it or something. So I'll go and measure up. They're about that size, so I'll go and measure one of them. In fact, those don't even look very long. Those don't look like the right screws to me, but that's what the three screws were that were in there. I'm sure there should be twice the length of that. That doesn't look like very much metal to hold this whole thing together. But I'll go and find a fourth one just to make sure I've got 4 screws in there. Yes, I couldn't find anything that's exactly the same, but as you can see I've got one with the same thread. Yeah, it's exactly the same thread. It's just, oh, I don't know, half a centimetre longer. But I think you could do with a couple of longer ones in anyway. These look too short for me, for the main, holding the main, part of the chassis together. So yeah, I'll swap one of these little weedy ones out and have two like that, and then 2 like that. So it's been cooling down for quite a while there while I've been reassembling it and stuff. So here's the moment of truth. I'll just switch it on. We should get, hopefully, a good picture. Bearing in mind it might need adjusting. There you go, yeah, it's in green. Let's push the green switch. I need to just reset this. Oh, it's in green. Why is it in green? Let's. Yeah, I'm not. Oh, yeah, I know what it's going to be. Yeah, it's these bloody switches on the back. Just bear with me. Yeah, I thought we've got another problem there. Start for a minute, but yeah, these switches on the back interfere with the picture. Hang on. Why is it now just green? Where's our colour gone? Yeah, nothing's ever as simple as it first appears. There are multiple caps I think need replacing on this. You can see it's looking blue now. Just watch this as I kill the main smoothing cap. You see it sort of faded out a bit, it's gone back blue again. I'll switch it off and I'll spray that cap. Just bear with me. Switch it back on. So it's green, and that was from spraying the main ballast cap, whatever it is on there. I think it's 150 microfarad, 400 volts. It's looking green now. So I think it was as I originally thought. I think we've got supply problems, but I think it's on multiple rails and things. I don't think it's just one place. It's not just that cap. I think it's like problems with the vertical, possible issue with the horizontal. I think pretty much all of the caps need replacing on this. But yeah, you can see it's green. It'll just, as it warms up, it'll go blue. You spray that main, see that large black cap there, and it goes green again. So yeah, gonna have to get a cap kit, I think. So it was a bit naive of me to just assume that it was just going to be that glue. That glue was definitely part of the problem, but not the complete problem. As I just showed there, when you switch it on when it's cold, you get like a green screen there. It's like, I think one of the voltages is low. And that was, you could simulate that by spraying that 150 microfarad 400 volt cap there, and that would make it go green, and after maybe 20-30 seconds it would go, the colour would come back, the blue background on the Atari here would come back, and it's a similar thing with the vertical circuit. Spraying around some of the caps around there, the flickering came back where it wasn't sinking and stuff. So what I've done is I've gone through and made a note of all of the main caps there, all the large ones. I've got lots of the small ones already myself, the tiny little caps. But all of the larger packages, the 16 volt, 35 volt, 25 volt caps, and I think there's a couple of 160 volt, I think it's three 160 volt caps as well. So I've ordered all of those, and when they arrive, I'll upload the second part of this video. But I thought it'd be interesting just to show you what I've got on with this so far, and as you can see, it does look really good actually. The colours are nice and vibrant stuff. It could perhaps do with a geometry adjustment or something. Can you see on the edge there? It's just like a bit bent inwards, just a little bit. I'm not sure there's going to be much I can do with that really. It could again be the caps. As I get through the caps and start to replace them, we may find the picture straightens out a little bit. But the colours, the sharpness, the contrast and stuff there, brilliant really. It's amazing. You just leave this on for about 10 minutes and this, it's like this now. It's it's totally usable. But it would be nice, obviously, to get it 100% with regards to the caps. Anyway, hopefully you found that interesting. Thanks for watching. See you soon.